Hey guys.
Hello.
Talking. All right, okay. Well, at least Alexandra's waving her hand. Um, Wesley. Hey, did you change your Zoom ID because it was Lay Wesley Beyond, right? Before you had
Yeah,
an
I did.
LEI also in your
I'll
username.
make sure I'll put that.
Oh no, did you edit it or did it automatically change?
I'm not really sure what's going on with Zoom. For the first week, I signed in from the Canvas page, and that made my name Labion.
So yeah. So how are you signing in now? How are you on this?
Now I'm going to the announcements page, and then you have the link there, and I click on it, and I think it's defaulting to my UCSD Zoom, which is this name.
So you're now logged into Zoom doesn't care if you're logged in. Well, anyway, for this particular meeting, it doesn't care. As long as you have the link, you can get in,
It
right?
looks like it.
Hey, can you someone try an experiment where you're completely logged out of Zoom and Canvas also, and you're not logged into a Foothill Canvas or UCSD or any other, right? And maybe even Piazza and things like that. Just so see if this link works in an anonymous browser window, because if it does, that's really cool. Basically we can open up the class to the whole world and say 8 a.m. Pacific time, anybody in the world can basically attend these meetings. I don't care, right? The more the merrier, right? So more interesting questions. We're not going to talk about anything less or more, but we'll talk about the same thing, and hopefully it'll benefit, and then we'll have more ideas bouncing around, right? And I think and I'm happy to moderate, because the best way is to basically teach each other. And you just need someone who has a little bit of experience to oversee the conversation.
I
right?
just
Or
tried
you-
it. It said unauthorized.
Oh, it did say
I just-
unauthorized?
Yeah, I tried to open the link from an incognito window. It says unauthorized.
Oh, I see. Oh, that's a bummer. Okay, well, maybe it works for Lay because he's logged into his UCSD thing. That's why it's such a coincidence. I picked up this change in your name, and I didn't realize that you can actually get into a Foothill lecture with a Canvas account of some other college. So basically, yeah. So as long as it comes through Canvas, Zoom doesn't care, apparently, right?
Yeah, that's probably it.
Yeah. So they must have some kind of deal there, but it's not. It's not being. It hasn't been configured right, obviously, right? Either it should be open or it should be restricted to a particular class. All right. So by the way, I did have a look at the video that you guys, after I disappeared, right? Last class, and it was really nice. We did. I don't think you guys managed to play the game. You wrote it, and it seemed. Does it work? Did you check it out? Does it work? Does the computer always win?
Yeah, the computer always wins.
Yeah. Okay. Cool. All right. I think what we can do today, if you guys are okay with it, at some point, not right now, right? So maybe 5 or 10 minutes later, if you're interested. Although because this week is supposed to be a looping and so on and so forth, and obviously in the process of doing whatever we're going to do, we'll touch upon looping also. And so I can take that program that you wrote before and show you a trick, right? Because this is a useful trick, and it's called refactoring, right? And refactoring is not just to do with people refactor code for various reasons, right? To try and narrow down bugs and make it simpler and things like that. But sometimes it's just helps to refactor code from one form to another, even though they may both be equally viable and efficient, just to see how the transformation happens, to get comfortable with taking parts of the code, changing it into equivalent, differently shaped code, right? And I think it's good experience for professional programmers, right? I mean, if you go to a ceramic studio, for example, right, and look at one of our instructors, right, Andy or Kim or someone like that, and they're teaching you, well, you know, you'll see, right? So it's just an amorphous. You just start with a wet bunch of clay, and the same clay. They, you know, they don't keep switching clay between. You know, I'm going to teach you this now, right, and now something else will take a different bunch of clay. No, right? Same thing. They take it, do something and show you how that's done, okay, and you get a chance to see what's going on, and then they mush it up, or you know, sometimes not even mush it up. They'll just make minor changes here and there and change it into a completely different shape. Now, you know, most of the time what will happen is that when as beginners, or at least I felt that way, right? To make one shape and go to another shape, I need to, you know, start again from scratch because the shapes look completely different to me. And to them, it doesn't look different because they've played with it enough to refactor, right? To break it down into pieces so that, you know, they start off as different, but as ordinary humans like us, we can only see the differences, right? But the experts, you know, like if you go to our classes and you actually see them working, right? You have to see them working also. And unfortunately, they actually give you lots of opportunities to do things in front of you and also teach you, right? So that's the great benefit of this community college system here. I think I love it, right? So we only see the same thing, right? It's we see it's two different things, two different people. You know, I can see they're going after completely different things, right? But you know, with experience, the master basically they can spot, right? In order to get here, you need to have got there first, right? There, and they, in their mind they can retrace all of those, and they see a point where they started to bifurcate, diverge. Right, so they can see it's actually the same. So they don't go from here all the way to, you know, a bunched up clay and re-wedged and back to here. They'll just talk here, and you see that this shape is basically changing into that shape. It doesn't go back to clay and come back. Do you see that analogy? How that makes sense? Right now. The thing is, it is good to practice that. It is good to practice that in coding, right? So if I say, let's write this program, many times beginners will say, okay, I got to write these 5 different programs. I got to start from scratch, right? So 5 times X effort. That's not right, right? And also tends to throw people off thinking, oh, there's too much work involved. But actually, there's not too much work involved because once you get reasonably good at it, it's not 5 times X, right? It's basically you do one, and then you don't have to go all the way back to the beginning, right? You just make changes and take it to the next nearest neighbor, right? And in your mind, you know, I got to do these 5 things, but this is the sequence I got to do it because the least changes occur, you know, from one to another. So all of those you would have worked out in your mind, and it's not a great deal of effort. That's why I think that, you know, taking one piece of code and changing it into another piece of code, you know, without making value judgment, saying they both do the same thing. And then you'll also get to sharpen your aesthetic senses. And maybe there's minor efficiencies and inefficiencies also will, you know, address, right? So, and then I'll also say aesthetically, maybe this looks better to me. So let's do it this way this time, right? And we'll try all that. So if you're interested, we can take that code, I'm hoping it works already, right? So we're not going to make any logical changes. So can you confirm that it's been debugged and it goes? Right, the minor bugs, we'll fix it along the way. But mainly we'll focus on refactoring the code, which I think is a very useful skill. It's not part of your syllabus, but it's going to be integral to your success in CS2A, because CS2A involves lots and lots of programming, right? You're going to be writing code, and soon you're going to be looking at a perspective of your program that doesn't work. It doesn't work. And I know even experienced programmers, right? Stuck with code that doesn't work. And they can stare at it for hours and hours, right? And they take breaks and come back, because, you know, taking a break and coming back is, if that doesn't work, there's very little chance something else will work. Maybe a couple of days away may work, but taking a break is the most powerful thing to help you debug your code, right? So they've done that. It doesn't work. However, I've noticed that when someone else takes the same piece of code and says, okay, I'll try and take a look at that code, right? But however, it's written in your style. So I'm just going to refactor it a bit so that it looks better for my aesthetics. So just refactor it a bit, right? And after the refactoring, before that other person spots a bug, this person finds a bug. I don't know if you've been working in circles that in which you've had the opportunity to observe these things happen? Has anybody ever seen this happen or been part of it or seen this happen to anyone else? Yeah, because it's not just in programming. It's not in programming. It happens in real life too, right? Many people unable to see the solution, right? Just because they're staring at the same pattern of occurrences in their lives, right? But the solution is right there. It's staring them in their face. It's because they're attached to all the wrong things. They're unable to let go of that frame of reference. So they're holding on to it, and the solution is not in that frame of reference. So the hard part is letting go of that frame of reference and saying these things don't really matter to the problem that I'm facing. What I'm holding on to is not the answer. So let me just relax there, right? Because those whatever happens in X and Y don't matter to the solution in this within this radius, right? Mathematically speaking. So you're going to let go. Previously, you were saying, even though I'm only interested in the solution of 2 meter radius, I need to now hold on to things 2 miles away, right? And we find it hard to let go because we think the solution may be out there. And I think what happens is that when you just restructure everything and let go, basically you're saying, I don't want this frame of reference anymore. I'll just, right? And take a completely different view of exactly the same problem, a different view, right? And we find the solution. And I think it is, we have to basically, that should be our motto in CS2A, right? Because other than math, right? Because, in physical sciences, it's a different kind of challenge, right? Because in my physics and other classes, I know, right? If something doesn't go right, it's probably 90% to do with physical dexterity or my eyesight problem or not noticing things and things like that. So I know I have to get better, right? Like in music also, right? If you're not getting something, you just have to keep doing it until, your mind is not doing it, your fingers are doing it. So, but it's not like that in math and computer science, those kinds of fields, logical, right? If something doesn't work, it will just basically niggle away. Right, and then it is frustrating because the solution is out there, and you're just not able to get it, even though you have the wherewithal to get to it, because you don't need anything, right? You don't need sophisticated equipment. You just need your mind, and you have a sharp mind, and you're still not able to pinpoint the solution. And that is a really annoying bit with math and computer science problems, logic problems. And so if you get used to the idea that in order to find a bug, right? In order to find a bug, we have to let go, right? We have to let go of preconceived notions about where we think the bug is going to be, right? Because as programmers, this is what we'll find happening is that we will, every time we find a bug, there is a huge part inside us telling that's where the bug is, okay? Because we always start off with a hugely preconceived notion that's where the bug is going to be. Well, most of the time it works out, right? Most of the time it works out. But I'm saying that, and it's good to follow your intuition, right? But many times it also leads us down the wrong path. And I think we just have to be aware. We have to be aware of the possibility sometimes that maybe that's not the place where the bug is, right? I've looked at all, like, Sherlock Holmes, was it Sherlock Holmes? If once the, what is it? Once you rule out the improbable, the impossible becomes, I don't know, something like that, some wisecrack, right? It was really cool, I think. But I think that is key, just to get used to the idea that you have to, if you have a bug and that is completely resistant, right? And that's, and you have to get to the place. And that's why I, even yesterday, I think last week, only 2 days ago, Rosa from chemistry, right? She is now managing the STEM Center. And so she emailed me asking, should I add tutors to your class? I actually, in the past, I had an issue with people from CS2A BC going to the STEM Center, and some of the tutors basically handing out the answer, right? Telling students, this is how you do it. This is how you pass the mini quest. But that, I don't know, some students were happy with it, I think, but maybe some students were not happy with that, all right? Because they want to know how to solve it, not be given the answer. And so I asked them not to add any tutors before at least I get to know who the tutor is. Lane is a fantastic tutor, right? Lane Johnson. If you go to the STEM Center, ask for Lane. He every single quest all the way up to CS2C, right? He knows not only the right way to do it, but also to nudge you without telling you the right way. He knows how to nudge you in the right direction, right? I've seen this happen in the STEM Center, and he was actually very instrumental in performing some of the 2C quests, or at least modifying. I don't know, maybe him or Paul before him, right? Paul Hader. So they were actually very useful and helpful in getting these quests together. So yeah, so I've said don't give solutions, because when you get answers from STEM tutors or anyone, your parents, your brothers and sisters, when you get these answers, you'll not get to the place in programming where you have felt a frustration deep enough that forces you to say that my solution is not even within the frame of reference I'm looking. So maybe I should give up some of my preconceived notions and let go of my frame of reference and actually look for the solution elsewhere. Find out what the hell is going on, right? And look at it with completely fresh eyes, as though you're a baby, right? A child being present with the problem and saying, this is not the way it should go. Why is it not working that way, right? And you don't know anything else. And then you start asking questions, right? So that is looking at it with a fresh frame of reference, and I think that will greatly help. So that's why 2 days ago I told Rosa that only had a couple of tutors. So if you do find a paucity of tutors in the STEM Center, ask me, and I will get in touch with Rosa and find out what we can do. But I think we have enough tutors, really, because right now I'm not even seeing a great deal of questioning. So, well, week 1 and 2, understandable. And I also week 2, I think we're finding more and more evidence that, lots and lots of 2B, not just CS2B, many other B level courses, students are not prepared at all for B. And they got graded on effort for the A rather than knowledge. So, if they put in a lot of effort saying, I had to deal with COVID positive symptoms and things like that, they basically got a pass. But that, that pass does not mean in the student's mind that, okay, now I'm ready to do 2B, right? I got a pass in 2A for some other reason. So that's why I don't give a pass, if for other reasons, last year, my class was exactly the same as any other year before, except for the question part. Right, and this year too. So there's absolutely no difference, because we are only grading on, not even grading, right? Grading is secondary, but if we grade, we are grading for knowledge, not for effort. And that's why one of the most frequent complaints I used to get from students before was that I spent 10 hours on this assignment problem, right? And this was before I had quests. Right, before I did quests, people had to write down their program things and send it to me by email. Was it email? I had some system, right? Maybe it was Canvas or Etudes or something like that. So I submitted and I would look at the code. And many times the code would just not run. It would be horrible. And they were expecting 20 out of 20 on assignments, just returning things in. And if it looked reasonably okay, but I would not and say it would not work. And they'd say, why doesn't it work? I show them it doesn't work. Fix the problem and I'll give you the points. But many students will not fix it and say, I already spent 10 hours on this assignment, but on my math assignments, I only spent 4 hours and I got my 20 points, right? I'm spending 10 hours plus on this assignment. So, I should get at least some points for this. But you can that's not the way it works, right? You can be a neurosurgeon and say, I basically, chopped up half your brain. I got to get my full fee, right? No, you got to do the whole job in order to get the points in a professional field like computer science, right? So otherwise, if you go to Gmail and type in half your password, you should get access to all your email, right? He shouldn't ask you for your whole password. So things like that. So computer science is different. And I think that people should stop treating computer science like another field, which is for, life enrichment also. Computer science is for life enrichment, right? In that case, you wouldn't be doing it for a grade. But if you're doing it for a grade, you're doing it to, earn money. But if you're going to do that for a profession, that means you got to be good at it, not just put in effort. As managers also, you'll find that, right? As later on in companies, right? There will be employees who would, put in hours and hours, right? Spend nights and days at work, right? And other people who just come in once in a while, right, for meetings and and talk random shit at work, but they'll get all this stuff done and they'll do a really good job. But yeah, and then but you got to make sure that everybody's happy at the end of the day, right? And so all of these things factor in. And we started talking about refactoring. So anytime you guys are ready, I don't even know if you guys have access to that code, right, from last week. If so, I don't know if you guys want. If you guys want, how long will it be? We'll talk about a lot of looping and other class-related stuff, and hopefully we'll still get time from 9 o'clock for you guys to take over, right, and work on something else, another interesting project maybe, right? And we can refactor until then if you guys are okay. Yeah. All right. How about someone who has access to that code? I don't know, maybe we look at the code and say, well, it doesn't even need refactoring, or maybe, no, I think we should force ourselves to say, all right, even though it doesn't really need refactoring, we're going to change some things, right, and see that it's exactly. But and the thing is, we also need to get good, and this is practice for you. You also need to get good at identifying two different things that are exactly the same. So right, they're called isomorphisms. I don't know what they call them. Maybe the isomorphism sounds like a chemical term, right? No, I think it's a logical or mathematical term. There are two things that are the same. So when I was a grad student, I had a math prof, right? And he was a knot theorist, right? Knot theorist is his whole life revolves around knots and braids, right? Braids where you take strings and make braids out of them, and knots like this, basically about topology. And he was so, I remember he was like jumping with joy when he could prove that two different knots, like totally two different knots, they're exactly the same knots, right? Meaning you don't have to do anything, you just wiggle it a little bit here, it'll turn into that one, right? You don't have to cut it or anything. And he used to be able to prove these crazy ass things. And that was, that's his bread and butter. Yeah, it's a very nice conversation. I used to have fantastic conversation. And at that time, maybe IBM still does that, right? IBM research.ibm.com used to publish a column every week called Ponder This, right? Interesting computer science problem. Computer science is a mathematical problem, right? With a solution which is not obvious. And people all over the world will take cracks at it. And you can Google it and find out. And he used to be very much into that, right? And sometimes he just come to my office and say, oh, here's that interesting problem, right? And then we'll think about it for a little while, and then it'll go away. And then later on, I go to his office, and he's already worked it all out in his head. And it's very interesting. Anyway, so if someone wants to take the code and pull up the screen, what we'll do is we'll start editing it, right? We'll start editing it. We'll try and make some modifications here and there, and then we'll also try and at some point later, knot theory. That's where I was going, right? You'll also get the practice of saying, well, these are two different programs, but they're exactly the same, isomorphic. It's exactly the same, just refactored. And sometimes the refactoring can be so different you can't even tell, right? Unless you know exactly what the program is doing, it's hard to tell. So it's a good useful exercise.
And now you're talking about the NIM code that was posted on Reddit.
NIM code. This is the one that you guys posted on Reddit?
Yes, it was posted on Reddit, but it was an image, not a text file. So I'm not sure who has the text file.
Oh, maybe Jared was the one who was it. Jared, was it you?
I think it was James.
Oh yeah, James. Yeah, James. Where the hell is James? All right. Anyway, so darn. I don't know. You know what? We can just get the visual. Yeah.
The thing is, I actually have a version.
Yeah, get the screen, and we'll just look at it visually.
Oh,
I have a version too.
Oh, it's like 20 lines, right? Is it 20 lines or less?
Yeah, I typed it out on my editor while everyone was doing it on theirs.
Yeah, don't worry. All right, let's do what Hiram is suggesting, right? Just take the screen, editor, and then we'll look at the picture, the GIF or PNG that Agnes was talking about, and then we'll just type it in, right? And in the process of typing it in, we'll just refactor it. And then we'll have the refactored code and the picture of the unrefactored code, and then we can compare the two and say they're the same.
Anand, when you refactor, what are you thinking about? Are you thinking about readability? Is it like
Yeah, I don't know. Now, right now, however, I just want to refactor for the sake of it.
Okay.
Yeah, I want to refactor for the sake of it so that we just get some practice and saying, well, because here, in fact, maybe refactoring is the way that, week number, what is it? Week 2 or week 3? Week 2. Is this week 2 or week 3 now? Holy cow, we're in week 3? All right. Okay. So yeah, this is looping, right? So I think refactoring is looping via refactoring. I think that should be the title of this week, because you know what? When we talk about loops, if you go to the textbook, they'll tell you like 10 different kinds of loops. Like one kind of for loop, another kind of for loops this way, right? And so on. 10 different kinds of loops. And then while loop and do while loop and implicit loops and recursive loops, all kinds of crazy loops are there, right? Now, however, they're all just loops. Now, if you learn it the textbook way, you say, okay, now I've mastered 4 kinds of loops. Now tomorrow I'll master 2 more kinds, 6 kinds, 8 kinds. Now at the end of 6 weeks, I need to know all kinds of loops. That's like a stupid way of learning loops. Yes. Right? So the better way is just say, what are loops? What do loops do? Right? Let me just learn one way of doing these things. Okay. Now I know what loops are. I know how to do it. Okay. Now you're good. You can do anything you want. Right? Now you learn one more way of doing it. Now you got 2 ways of doing what you want. Right? So I think that's a much better way. So I think computer science via refactoring. That is the better way to teach computer science, is to basically teach you one way of doing something and then teach you 100 different ways of doing the same thing, so that you can apply a different way as a situation demands. Because at the end of the day, what do you need, right? So at the end of the day, any skill, computer science, whatever it is, right? At the end of the day, what we want is basically different ways of doing different things. That's all, right? We don't want to learn how to build any particular thing. We just want practice and different ways of doing any kind of thing. So that, in a brand new situation, we can just break it down in little parts, right? And each part we know how to solve in, a couple of different ways, so that we can pick the one way that is, the most friendly with all the other ways you're going to pick for the neighbors. So, that's how we're doing it. Every time we solve a problem, it's basically a jigsaw puzzle, right? Because, we know how to solve these little problems in many different ways, but we want to find the best ways of solving these little problems that mesh together in the best possible way. Yeah, so it's basically an optimization problem. Right. So that's what we're doing with code today, and hopefully, along the way, as we are refactoring this code, we'll discover or talk about certain things, right? Saying, all right, no, this particular refactoring we're doing for an aesthetic reason, because I like it, right? Or this we're doing because it'll save us a variable. That's a valid reason. Yeah, less typing, right? And so on. So we can do all those things, and we'll say, this we're doing because we can save a level of indentation, right? Because indentation is a pain in the ass. I don't know, right? So yeah, once you start coding, right, indentation is a real pain, because especially with HTML documents and XML tags, we know. Right, and then we're such a pain because everything gets indented, and and then people said, okay, let's not indent it by 4 anymore, because if you indent by 4 spaces, HTML basically just runs off, screaming past the right margin. So they started indenting by 1 space, but even that is so unsightly and it's hard to maintain, crazy, right? So does everybody feel the pain of indentation? Right? I want to, because before I make my next point, right? Does everybody feel the pain of indentation? I know it's a necessary evil sometimes, right? Because it improves the readability of code, but it is still a pain, right? Yes or no? Because if you can have equally readable code without indentation, we would do it. Yes or no? Equally readable code. I'm not saying, right? So we have to imagine this, because it's harder. It's hard for us to imagine unintended code that is readable, right? But assuming that if we had equally readable code without indentation, we would go for it. Yes or no? Right?
Yes.
Yeah. So indentation is a pain. Indentation, in fact, programming itself is a pain. You can argue in the same way, but because if you can just get something to happen by just thinking it, right, without having to do anything, if you can have something happen by thinking it, we would do it. Yes or no? All right. The fact that we have to go through the pain of an empirical process mediated by the material world is just a side effect or a necessary evil, right? In order to get to what we want. So we just learn to look at, indentation as a pain, but so because indentation is a pain, what we now, because we acknowledge that, many people don't acknowledge that, right? Many people, just like in real life, the other analogy that I used, right? Many people don't acknowledge that indentation is a necessary evil, right? So they say it's a good thing, you have to indent. No, it is okay. It's a good thing given these considerations, but and in an ideal world, it's still an evil. Which means that if I can minimize that, I ought to, right? So the insight that if you can minimize indentation, you should minimize it, right? That insight, because it actually improves readability, would not have occurred to people who basically believed the intrinsic goodness of indentation. Because they'd say, no, indentation has to be there. I can't get away. It's good. I shouldn't get rid of it. Right? So they wouldn't have the other perspective saying, well, if I look at it from here, well, it's good here, but it's not good anymore. So if I can get rid of it, I should. And so by thinking from that perspective, many programmers, after many years and years of programming, subconsciously develop a bias, I think. Because when I see them coding, and there is a possibility to write a piece of code with one level less of indentation, they would just do it subconsciously, bam, like that. Right? And I'll show you an example today. Right? If you have an if statement, if something, return, right? Else, indented block, bam, 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 right? So obviously you don't need that indentation or the else, because if something is going to return, well, we'll come across those situations, right? Let's refactor this code. Maybe we'll see. Right? Maybe we'll use this code to the way we make the changes. I'll talk you through the changes, right? So in case. So you should, one of you should take the code or a blank screen and also show me that window, or I can pull up the window, right? I can pull up that image on Reddit. Anyway. So let me move my Zoom window to the other desktop here. Okay, so and let me go to Reddit. Nim code from class. All right. Oh wow, it is actually an image. I didn't realize that, but I did believe you. But it looks so code-like. All right, yeah. Well, yeah, I can see the code. I can go to the other desktop and come back here and talk more. So if anybody wants to take the screen and start up an editor, we can start coding, and then you guys can independently get the Reddit code in one of the tabs, and then the code that we're doing in another tab, and then look at them side by side and convince yourself that they are exactly the same, right? Because you got to convince yourself. And because you think about it, this is exactly what you do in math all the time, right? How many of you are involved in doing math courses, right? You have the identity proofs, yes? You have, sine squared x plus cos squared x equals 1, right? I don't know. This is a very simple one, but you have, more complex identities, right? And they don't look the same at all, right? Like e to the I pi equals -1, different worlds altogether, right? But it's an equality right there. So how do you prove it? How do you prove that these two quantities are exactly the same? And how? But you start off with simple ones. Yes, in math, you start off with simple ones initially. In trig proofs, you start with simple proofs, right? And then slowly, as you get practice, the left-hand side and the right-hand side, they'll start getting more and more different, right? Yes, more and more different, until such time as the left has diverged so much that it's no more recognizable as some variant of the right side. But they're the same, because how you got to the the leftmost left from the left and the rightmost right from the right. How right, so they're the same. That's exactly how it works in computer science. A lot of people, right? So you start with programs, and in your mind, you're going to create lots and lots of little programs that are exactly the same, right? And they'll all change, but you'll be able to map them, right? So it's all a graph. It's like a graph. And so you'd be able to adapt, adapt, change, and adapt, and then you'll get the problem, your quest solution. But you'll see, right? I think, maybe not in CS2. Or maybe between 2A, yeah, once you get to 2B, right? You'll find a lot of your code is reusable, right? A lot of people think, oh, CS2A is so hard, I'm gonna get to CS2B. But yeah, surprisingly, if you've done my section of CS2A at the very least, right? And if you stuck with this class until the very end, you will be in the top 2 to 5% of the CS2B class of students who may not have done this CS2A, right? Because if you get to question number 9 of CS2A, it's almost identical to question number 1 of CS2B. And CS2B gets challenging for those who have not done CS2A. But if you're solid with the mechanics, right? Different ways of using for loops, in your mind, you know that this chunk of program code is identical to this chunk, although they look very different, they're identical, right? In your mind, you know that, which many people don't. And not many people out there. Many people enrolling into CS2B graded for effort on CS2A or something like that. They don't, and so that saves a lot of frustration, disappointment, right? Because the reality is that the person didn't know. The truth of the matter is that the person didn't know computer C++, but they were graded on effort. So the person needs to be wise enough to understand and be grateful and kind, saying, thank you for passing me, even though I don't know anything of programming. Thank you, I'm grateful for the pass. However, in order to justify the pass that you've given me, I'm going to go and fill up my missing knowledge. I'm going to go and learn CS2A before I go on to CS2B, right? That is the right way of reciprocating the goodness or the being grateful to an instructor who gave you an A for the effort, right? Not to say I've got an A, now I'm going to go and conquer 2B with lots of effort but no knowledge, and that doesn't work. So I really hope that winter, this is fall, I hope that a lot of you will enroll in my CS2B, stick through CS2A, right? And complete it. And a lot of you will enroll in my CS2B. And also set an example for other students. Anyone who quests or does or learns worldwide. As you know, all the material is open now, right? So I put all of LOSAF's notes online, free, open to the whole world. Questing is open to the whole world. Anyone who's interested in computer science can do the class, participate in our Reddit. You guys can answer their questions, and they can answer your questions. Everything is open, right? I don't have to care about the servers because for the discussion forums wise, Reddit is under control for decades now, so I don't have to worry about that. Questing, I've already architected that, right? So it's to take care of itself. So that's not a headache for me, hopefully. So it's basically open and it scales. I've paid for it. I've paid for it to scale hugely if necessary. So say ask people to try it, right? The more people that actually learn computer science in the world, right? Not here. This is my feeling. Okay, the sooner the world population will emerge from this false notion that just learning to put things together does not make a programmer. Okay, just like and it's quite natural. A long time ago, a lot of people thought, I'm talking about many thousands of years ago, right? Maybe many thousands of years ago in Egypt or ancient China or India, when they came across these algorithms for addition and subtraction, right? Carry and borrow and things like that, and they did that. Maybe only the learned people could do that, and then slowly, the kids started to use these techniques to do these additions and subtractions, and then for a period of time, anyone who could do these sums could say, I'm a mathematician, right? However, the true mathematicians out there, they develop these techniques to help them develop complex thoughts that are still the same today, right? They were talking about complex thoughts and using these symbolic manipulations and the calculus they've derived to come up with these answers, right, as ways to talk about these things. So, but a kid or some other person who's just learned to do sums saying, now I'm a mathematician, I can help you run your store and keep accounts, as well as talk true mathematics in right. So that phase has to go, and before real productivity starts to happen, right? Because then the people will start appreciating the power of computer science at a younger age. right? Now, because now people think because I can put things together, I'm a programmer. In maybe 10 years of time, they'll think maybe in high school, I'm not a programmer yet, but I can change this from a linear algorithm to a logarithmic algorithm. So I must be a programmer. Okay, that is more sensible, right? Because that's really what true computer scientists do these days, right? So think about those things, and that's where we need to be. And that level, is now at college graduates, right? And then now it's filtering down to boot camps, right? Lots of boot camp graduates are starting to appreciate that real computer science is to do with efficiency, right? And how to make the computer do less work, right? Then because the same thing can be accomplished in a million different ways, but a computer scientist knows how to do it, accomplish it with the least amount of work, right? And I've made this analogy before. Anyone can build a cave, get a huge amount of stones, right? And dig some out, right? And go in there. That's a cave. Anyone can build a cave, right? But an engineer, a scientist can build a cave with the least amount of stones and the least amount of effort, right? Because they can do all this in their head and they can figure it out on a piece of notebook, right? The notebook with a pencil, they can say, well, I've got all these stones, right? But I'm not going to go and build yet because I'm going to use my mind, right? And work out some sums here and saying, okay, if I do it in this particular way, I don't have to move my ass that much, right? Or I don't have to spend that much money, right? I can use the least amount of stones. All these things will factor into an engineer's outlook. And that's how computer science works also, right? So many ways of doing things, but you can bring your engineering mindset to bear, the scientific mindset to bear, to say this is the optimal way to do things, right? So I don't know, we keep talking about these things. Nobody's picking up the code. If someone can pick up the code and open an editor, we can start coding as soon as, right? Just share your screen and an editor. I think what we can do is let me take a look. Why are people trying to? All right, Agnes, thank you. All right, I was getting very close to nominating one of you guys. Okay. All right, let's start typing in the where's all right. I'll just go to the other desktop. Oh, you went full screen. That's why it went. Okay, let me move this desktop out of the way. All right, so yeah, let's do the standard stuff. A hash include IOStream using namespace, and then int main, and then, in fact, what we can do is start typing this in. I'm not looking at what you're typing, Agnes, so I don't know if I'm going at the right speed. So let me actually go here. Hey, how did you get it? You finished the typing in?
No, thank you to Jared for keeping the code and sharing it with me. But Zoom is giving me this weird issue where it mutes me and I can't talk
wow,
while
I can hear you now. I can hear you now.
Yeah, so I'm gonna go back, but I could hear everybody. I think if anybody talks, but for some reason,
no worries. No worries. Yeah, leave it like this. Yeah. It's better to hear you now. Yeah, I think this is great. Thanks. Okay, hash include IOStream, int main, int pile equals 13. Okay, well, here is something that I didn't show you before. For a pile, in place of 13, type this, right? In the place of 13, say, double click and say, rand open close parentheses, space, percent, 100. I think, and also I think you say +1 there, because, all right, percent, put in a space after the, around the percent, and the +1 also. Yeah, plus.
Hello, Professor, can you hear me?
Yes.
I have a file for it, but on Reddit, I was unable to share anything through files. I think it's only like PDFs and stuff like that.
It doesn't let you share files. Jared, I think what we used to do before is to share the, see that share link. I think GDB online GDB gives you a share link.
A share link?
I think so. Agnes did it once. I don't know. We got to check with her. Okay. Or someone else did it once, I think. I don't know.
All right, I'll look into it then. I
Yeah,
guess.
yeah. Oh, all of these sites give you a shareable link.
All right, awesome.
Okay.
Thank you.
Cool. All right. So I'll put a comment above that, right, to explain what it does right now. For the benefit of students, we're going to look at the code later. But before I put the comment, can someone tell me what that line is actually doing?
So I think rand, I'm guessing it just gives you any positive random integer, and then you're taking the modulo of 100, and you're making sure that if rand is, or if rand divided by 100 has no remainder, you still have a pile, so you add 1.
Right. Is everybody clear exactly what Alexandria said? I want to make sure that everybody understands that. Can anyone who does not understand what Alexandria just said, please speak up now, right? I will try and explain it in a slightly different way.
Could you try explaining it, Professor?
Okay. So what's going on there is that rand is a library function, right? And in order to use that, we need to tell the library, to tell the compiler that, you know, that there is a function called rand. Otherwise, the compiler will start barfing, right? So let's go right to the top after hash include IOStream. After hash include IOStream at the top. Yeah. Yeah. Enter and say hash include. Same as IOStream, except now we say CSTDLIB. CSTDLIB. Now, what that is a C standard library, right? CSTDlib is a C standard library, which means that all the functions that used to be so handy in C, that were put in a standard library for the C programmers from decades ago, they're so cool. C++ programmers also want to use them. So I want to use them. And the way I use them is to say, I'm going to use them up there, saying, oh, that's a C standard library. Now, rand happens to belong to that C standard library, so I can use rand. Is everybody okay so far? Okay, so what rand does is basically give you a random number from 0 up to a defined value, right? Some constant value that is defined in the standard library called max rand. I think it's called rand max, right? Some huge number. This is 30. Open a tab in this in the browser. Open a new tab, a brand new tab in the browser.
I was just sharing a tab, so let me share the whole thing just a moment.
Sure. No worries.
Professor, did you say it takes a random number from 0 to random number max?
Yeah. Oh, there she is. She's actually done it. Yeah. Okay. So rand is that is the documentation. Hey, Agnes, can you go back and show how you got to this page so that someone who wants this to get to this page will know what you did?
I just put rand C++.
Yeah. Go back to the Google search thing.
Oh,
right?
Okay.
Right. So anybody who wants to locate information, this is how you do it.
Just like the first thing.
Mostly it's the first one, right? Most of the time it's the first one. Yeah. Right. So yeah, now you can click that to tell you what rand does. Now the other thing is you can go to the ancient primordial definition of rand, right? When it was first written, right? What is rand, right? Even before these pages came together, they were part of a distribution of an operating system called Minix or Unix, right? And it used to be in files, in one file that says what rand does, right? So open another tab, open a brand new tab.
Okay.
Right, now type man space rand, right? What that says is bring me the manual page, right? Manual page for rand in the Linux operating system. Right? If you click that, it tells you what rand will do, right? And this is what the other page is based on. This is the original, right? The other one is based on this. This is a disk version of this page, right? So this tells you that this gives you a random number, a pseudo random number. We won't go into the details of what is random and what is pseudo random. We spent hours talking about this in previous quarters, right? So, and it's very nice discussion, not just on in the recorded lectures, but also on Reddit, right? Very nice discussions on what is random, how you can generate random numbers, right? Efficiently and so on and so forth. So you guys should look it up, right? Even the right. So these pages are fine. So let's go back to our code, right? So what it does is it gives you a random number from 0 all the way up to rand max, which I believe is 2 bytes.
Yes.
It's 2 bytes. It's 2 bytes. I think, right? 2 bytes is 65, but it's signed. So it'll be 32K, right? So 0 to 32K. So random will give you a random number, uniformly distributed. However, you don't know if it's uniform, right? That's why it's pseudo-random, right? Uniform, which means that any number is equally likely from 0 to 32K. However, that's too big a range for us. We don't want 0 to 32K. So we're going to divide by 100 and just take the remainder. And that remainder is also going to be uniformly distributed between 0 and 99, 0 and 100, right? Well, actually, it is not strictly speaking uniform because there's what is called a modulo error, where that's all part of mathematics, right? If you do Patrick, it keeps saying Patrick Stewart, right? So Patrick Morris in our math department, right? Well, he's on PDL sabbatical this year, but he teaches a course, discrete mathematics, right? If you do that, you can have these discussions in class, or it's fun. But if you do apply modulus, the distribution is destroyed. But it's not destroyed so much that it affects our simple tasks like this. So we're putting up with two things. We're putting up with artificial, not truly random numbers, that's pseudo-random, right? The other thing is that we're going to do the modulus and get the number smaller, right? Suffering a small, again, deterioration in the randomness, right? But not noticeable, right? Like going from Einstein to Newtonian mechanics, right? So there you go. So it does that and plus 1. Now we get a random number between 1 and 99. Is everybody okay so far? Right, now you can put a comment on top saying generate a random number from 1 to 99 inclusive. Right, so we stuck a comment in the process of refactoring, right? We stuck a comment there so that it'll help us and help other students who look at this code later. Okay, now int remove, int computer remove. So yeah, I need to look at the logic here. I haven't looked at the logic and I just took your word for it. Let's forget about the logic now. We're looking at refactoring, right? We'll come back to the logic later. Okay, all right. So while pile greater than 0. All right, so you got a variable called pile. All right, while the pile has pebbles in it. Okay, remove 1, 2, and you get to remove. Okay, so out. Okay, all right, let's refactor this a little bit so that we can reduce some indentation. Everybody okay with that? Okay, good. So one of the techniques, tricks that I use, and a lot of programmers I know use, is called the easy out process, easy out exit. Have you heard of this? Right? I don't know, I just made up those words right now, right? So easy out, meaning that if you're programming and you see a way to exit the function, right? If you see a way to exit the function, you got to take it immediately, right? Yeah. All right. So now we know that if remove, you're calling that remove, right? So we'll change these names later, maybe, right? But I'll give you some suggestions. But this remove is good enough too, right? So you know that if remove is got to be 1, 2, or 3. If it's not 1, 2, or 3, you're going to give the user a message and go back to the top, right? You're going to leave the rest of, essentially you're exiting the loop. You're going back to the top of the loop, right? Break. There's 2 ways to leave the loop, right? Break and continue. Yes. You got to read about loops for the rest of the week, right? Break and continue, right? Break says, break out of the loop. Continue means, break out of the sequence and go back to the top and repeat, right? So it's 2 ways. So they're both called exits from the current flow of equations, execution. But they're not called, right? So I'm just saying, right? Now I'm calling, right? So what we're going to do is, if remove is greater than 3, let's change that. Yeah, change that. Well, if remove is greater than 3 or less than 1, right? Yeah, remove is greater than 3 or less than 1. So remove is greater than 3 or remove less than 1, right? Now see, and now your cout message can be slightly different, right? Sorry, you got to choose 1, 2, or 3. Yeah, sorry, you got to choose a number between 1 and 3. Or whatever, number, choose 1, 2, or 3. Yeah, great, that's much better, right? And you got to put a full stop after the 3, because that's the end, right? Full stop after the end, yeah, all right. And then now we're going to take the out, meaning that's it, right? Once you've told the user this, you want to go back to the top, yes or no? You don't want to do anything else.
Mm-hmm.
Okay, good. Now, so now at this point, we're going to say continue. Right, next line. After the cout, after the cout, put the semicolon. Do you have a semicolon at the end of the cout?
No. Oh, here. Yeah.
Oh, you know what? Hey, Agnes, right click on that vertical bar that between the two left hands of the key, yeah, and drag it all the way so that it's
Ooh, can it be dragged? I don't know that it can. Hang on.
Yeah, it doesn't give you the option to. Can you click that X next to the C line? You have the X there. Yeah, click that.
No, that's a clear.
How do you get only one window? Only your code and not the, is this online GDB? Oh, it's Replete. Yeah, okay. All right, different environments. Replete, I'm sure we used to do this before. I don't know. Maybe it's one of those three icons. Maybe it's one of those three icons on the top. You have these three icons next to the share.
No,
three different people. Those three different people. All right, let's not waste time on that. Okay, so I think this is okay. Right. So after the cout, semicolon. Yeah, go to the next line and say continue. Right. Okay. Now it and then remove 1, 2, or 3. Let's also change the message so that and it starts at column 1, not column 0. Remove starts at column 1. Right. Remove the space in front of the remove. Remove the space in front of the remove. No, not there. Oh, I'm sorry. I'm talking about line 15. Line 15. Right. And we want to say, because it's going to be in a loop now. Right, we want to say you want to say on the previous line. Actually, go to the previous line now. Previous line, yeah. Enter and say cout. You want to say there are this many pebbles left. Right, there are. Close the quote and then left shift pile. Yeah.
Left shift.
Pile. That's your variable, isn't it?
Yeah.
Yeah, and then within quotes again, pebbles left in the pile. Right? Okay. Now endl there, or you can say /n. Yeah, okay. All right. Now remove 1, 2, or 3 from it. Right? You can run and you can get rid of the pile, the first, from it. Yeah.
Oh, just get rid of this whole thing.
No. Get rid of the less than pile, the double less than pile, right at the beginning, on line 16.
This.
Line 16.
Sorry, 16.
Yeah, I'm sorry. I'm just saying less than and instead of left shift, right? Yeah. No, you have that cout double less than and then pile, right? So we say, just say cout double less than, and then you can just say remove. Yeah, exactly. That's what I was trying to say, and I was having so much difficulty saying that, right? And you can say remove 1, 2, or 3 pebbles from this pile. From it, I think. From this pile is fine. Okay, and then and then the colon. That all looks good, right? And then you're going to say see and remove. That's great. Now, if remove is not valid, you're just going to go to the top of the loop. Yes. So if you don't go to the top of the loop, that means remove is already valid. Yes or no?
If you don't go.
Right? If you don't hit the continue, you have the semicolon. You put the semicolon after the continue.
Oops.
Right? Now, now on line 22, if you're at line 22, imagine you're the CPU, right? If you're at line 22, I'm going to reduce the size of the font so that I can see more of you guys. Okay, I can still read it. I think I can still read it. Okay, sometimes I might ask you guys what's on screen, but I think I can read it. I can see all of you. All right, good. So this is a very important point. If you're on line 22, are you convinced that the value of remove is valid? It's not less than 1. It's not greater than 3. This is called an invariant. Okay, in mathematics you call it an invariant. You got to prove this. But in your mind, you have to be convinced that it is true, because there is no way a program is ever going to work that you write, right? In your life, no program will work unless you can have these, self-evident truths following one from another. one another, right? That is true. Therefore, this is true. Therefore, this is true. Because a program is basically an exercise in deductive logic, not inductive logic, like empirical sciences. Okay. So in your program, you got to establish before you give to your customer, you got to say, this condition is true, right? And every sequence of permissible actions starting from this condition has got to be true. Because all my permissible actions lead you from truth to another truth. So as long as you only follow these permissible actions, you'll always end up only at truth. Right? So even if it doesn't know, it doesn't matter. Even if you write a 1,000,000-line program. So that is a way to write a huge program, right? With a team of thousands of developers, right? Scattered all over the world. It is impossible. It's impossible to do it unless you basically, work with each or develop a level of trust, saying that, what I get from a person is guaranteed to work, is correct, right? So once you have that trust, then you can start building on top of that. Then you can build a bigger bridge, saying, okay, now this tone that I get from a mason is that's going to hold. The next one is going to hold. I can stand on this and lay the next one, and so on and so forth. And that way you can go from, build the massive program before you know it, your enormous product will be done, right? Just because each one of those you followed on. Now, a lot of people miss out on that, right? So, and that is where a lot of bugs, even if you're experienced, right? And even experienced programmers, this is what they're always trying to refine and get better at, is to get better at predicting these little jumps. And many times we don't go through the mental effort or the incorrect laziness sometimes. Or, I think it's overconfidence, right? Unfounded confidence that something is going to work. We just assume that it's going to be true. That jump, right? That proof in the math is going to be right. So yeah. Okay. So you just implies, and everything is true, right? But one thing is actually not true. This doesn't imply this, right? And then you get your answer paper back from your math prof, right? And you see reading, a little circle there. Okay, your derivation is, you think it's right, but that step doesn't follow. So come to my office and explain that step. How did you get that? And I don't know. It's happened to me. All right. Okay. So, well, meaning that I was on the receiving end, right? So I had a proof that was wrong, although I thought it was right. And the same thing happens with programs, right? And you'll think that a program has got to work, but it doesn't work. And that's because one step of the way, you thought that something should work without fail, but you forgot to account for one condition where that will fail. And that is called a corner case. I don't know if we talked about corner cases before. It's called a corner case. Corner case is something that you never encounter except in very rare situations, right?
Oh yeah, corner case or edge case, right?
Edge case, yeah. And if you don't account for that, then your bucket is not leak proof, right? It could break, and meaning that your customer could traverse a path. Your customer can traverse a path from the absolute truth you gave them, right, through a set of rules you gave them, guaranteed on paper to lead them from one truth to another. So as long as they use your rule set, they are guaranteed to always stay on top of correct results, right? Because they jump from truth to truth, right? So, but if one of the rules that you gave them wasn't checked properly by you, and you tell them you're allowed to do this, but they're not actually allowed to do that, and they do that, and they end up on something that is shaky ground, all right? They're not at fault, really, right? Because you allowed them to do it. You should not have allowed them to do that, right? And that is why some companies, right, who keep the product really tightly under wraps and say, we're not going to give you a great deal of freedom, right? You're not allowed to change the product willy-nilly as you see fit, because you don't know. Many times users don't know what's good for them, right? Because they don't have the time and effort to sit down and think, this is the best way I should be doing this. And so they'll end up screwing up things, right? And so instead of being completely open, right, you got to have a benevolent dictator who says, right, you can change the language as much as you want, right? But I'm just going to keep an eye on it, right? Or you're going to change it, you can change your product, right? But I'm going to keep an eye on it. And I'm not going to, and I think that is the direction in which some operating systems try to go. Yeah, and some products went the other way too, right? As you know, like I think the Apple ecosystem, for example, says users don't give users too much freedom, right? You just keep them tightly reined in inside of these well architected pathways, beautiful pathways, right? Maybe it's annoying to some people, right? But it's well done by us, and we've tested it out with different kinds of human beings, right? Everybody loves it. So just don't try other things before you completely exhaust enjoying what we've already given you, right? And so they won't let you do anything else, but you're guaranteed to find fun things to do within their universe. So so there's different ways in which you can do your product, right? So it depends on how much control you need over.
Professor?
Yeah, sorry. Yeah.
I have a question. So I just ran it on mine as well on my end, and I also got 84 pebbles. Is that just a coincidence that
no
Agnes got it as well?
Yes, thank you. How did you? I don't see 84. Where is 84?
It says right
Oh,
there.
yeah,
On the
there it
right,
is. There are 84.
pebbles.
84.
And
Yeah,
I
yeah,
also
yeah.
have, and I have another question. Or just answer that one first, actually. Sorry.
No, go ahead. Go ahead. More questions are better.
So also I was trying to rerun it through my wanted to play it again. So I kind of went from 84 and then removed 3 and 3 and 3 and so on. And it had 84 pebbles again. So do you have to like reset the random number or?
Yeah. Okay, I'm glad you brought it up. And again, well, I don't know how much I should talk about this. I'll be very brief, but we've talked about this at length in previous classes when we talk about RAND. Okay, the problem here is that RAND is generating a uniform random is really, really hard. It's already been generated, right? It's already inside. Although you don't know it, it's there. A million numbers or 32 random numbers in there. And every time you ask for RAND, it's going to get a number from that list. And it's always going to start at the same place, right? 84 apparently is the same place, right? So it's a remainder, right? It's going to get the same number. So to get different numbers, what you need to do is to take that needle, which points to the place where you're going to get the next random number from, and you're going to give it a whack so that it does that and settles in a random place. Yes? Okay, within the table, it's a table of fixed, if you keep on calling RAND, you're going to get the same number, right? You got 84, you call it a couple of million times, you'll see that 84 occur in exactly the same place every 32,000 times, because it's going through the same table, right? It goes to the bottom, it goes to the top again. So it's basically going, right? So all you need to do is just reset that pointer to say, start somewhere else. Don't always start at the top. All right. And one way we do that is by calling what is called srand, another function conveniently provided by the standard library. And Agnes, you can go to type man srand. Yeah, srand C++. All right. The pseudo random number, it can be initialized, right? You call that function and it will initialize your pseudo random number generator so that you get a different number each time. Now you initialize that to say, but you're going to tap it, and let's say Alexandria is also going to tap it, right? How do you know you're both going to tap it with different velocities, different pressures, different forces, right? Maybe you both tap it and it settles out at the same place, right? So you'll end up getting. So the way you do that is by saying, well, you know what? I'm going to tap it with as much force as I get from the last second on my clock, my computer clock, or something like that. Yes. Then the chances are much lower that Alexandria and you will tap the needle with the same force. Okay, all right, good. So let's they must have an example. We can just actually copy line number 9 in that. In triple click on line 9. We'll use that. Triple click and triple click. Actually, no, try triple click. I want to see if it works, if it's a frame. 3 clicks. Oh, it does work. Okay, so it is a frame. Yeah, copy that and go to your code. And then put it on. And when you call srand, it should be called exactly once, and it should only be called in main as soon as main starts. Okay, because that will save you from the accident of calling srand multiple times, especially within loops. You should never call srand within loops, right? You'll know the reason for that. Right. All right, there you go. Srand time null, and and rand should be called after srand, right? Obviously. Right, so because srand is your initializer, so rand should be srand should be your very first call, even before you call rand. You triple click on the line and move it to line 7. Yeah, all right, and then a blank line after that. Right, and then you can comment srand you put a comment on srand on the same line saying look up. Oh yeah, you can put it there. Look up Google srand. It initializes rand. Google srand. It initializes rand, or something like that. Yeah. Yeah. All right. Is everybody okay so far? So we made some minor changes, not really refactoring so far, but now we can do the refactoring. Get rid of the, else. You don't need the else, right? Because you know that it's a valid thing. So you can get rid of the else and save an entire level of indentation. Go to line number 26. Get rid of the word else, and that if can go, right? That entire if can go, because it's a valid number. No, just that line. Just the line. All right. Now pile. Now pile remove is valid, right? So you can decrement pile. So you can say pile minus equals remove. So instead of pile equals pile minus remove, you can say pile minus equals remove, which is exactly the same. Minus equals. Everybody okay with this? And again, this doesn't need to be indented, right? So you can in fact, you can remove the indentation before pile equal minus equals. Right. Okay. Great. Okay. So on the next line after that, line 27, what are you doing? If pile equals 0, you lose. I don't understand that.
Now it has to be pile is less than or equal to 0. That's the.
I see. So okay, yeah. All right. So change that to file. If file less than or equal to 0, you can say you shouldn't. You lose is not a good message usually, right? Nobody likes to hear that. I think. So you should say sorry, your pile size fell below 0. Exiting, right? You tell the user what's going on, right? You lose, and then that seems like your program died or something. Yeah, became less than 0. Became less than 0. And then you should also change that if statement less than 0, right? Did you say less than or equal to or less than?
Less than.
Less than or equal to.
Because if it's 0.
Well, that sounds very mathematical. Hey, can someone think of a way to say that your pile became empty? Your pile became empty? I don't know.
You don't have a pile anymore?
Hmm?
You don't have a pile anymore?
Yeah, you don't have a pile anymore. Yeah. Oh, yeah, but no, it became empty. Yeah, don't have a pile anymore. That's good. All right. So now you can basically exit, right? You can get rid of you got too much indentation in front of it.
Yeah. Does it auto?
It should auto. Yeah, it should auto. Right. And then you need a new line. You need a new line after the anymore. Oh, you do have it. Okay, good. All right. So after that, you say on the next line you say exit, or return, or exit, or whatever it is, right? No, inside of the if statement. There you go. Exit, and then open parentheses.
Here?
I know inside exit is a function. We're going to call exit,
right?
Right? Exit, and give it the value 1. Right. What we're saying is that I want you to go back to the operating system, but don't go back and say that there were no errors. Actually, say there was an error, which means it was an abnormal exit, right? And normal exit means an exit of 0, no errors, right? An abnormal exit is a non-zero exit, meaning something non-zero happened. Okay, and the number tells you what that had. But so you say exit 1, and that's it. No, you don't need the else and all, right? So because you're exiting right there. Right, so fix up the indentation on the first if statement, right? That if statement, that brace needs to go back to line up with the I, right? And then enter right there after the thing. Enter. Okay, great. Now, sorry, you don't have a pile anymore. You put the word exiting right after that, so the user knows, right? Exiting after that. Okay, good. Right, that's much better. All right. Now you don't need that else, right? Because you know that if the user lost, it would have gone. No, you need the else, whatever the code is. You don't need the indentation and all that stuff, right? So get rid of the else line. Get rid of line 34, right? And now, what is? I say computer remove. You're calculating how much the computer is going to remove. Yes. All right. Now pull it back. You don't need the indentation. right? And you know, I like that blank line there. Yeah, okay, good, right? Yeah, I have 4 minus remove. Yeah, I think that's good. That's good. 4 minus remove, because we know that remove has got to be 1, 2, or 3. Yes. So 4 minus remove, and then pile. Now, and then, but instead of just saying pile equals that, you also got to say what the computer did, right? So on the next line, you say C out. On the next line, you say C out.
Which line?
After on line 36. On line 36.
Right. Okay.
Line 36. You say C out. No, I took this many. You say within quotes. You say I took computer remove stones or pebbles or whatever it is. I took, and then yeah, and then yeah, code, and then left shift, quote left shift, and then what is it? Computer remove.
How much?
I wish that variable was a smaller length. You know, you should say n, maybe n equals 4 minus. You just say yeah. Actually, let's do that, right? Because you know, just make that n, not computer remove. N equals 4 minus n. N. Oh, I see. You already have a variable declared up there called computer remove, but you're not using it up to. You're not using it until here. Yeah, get rid of that. You don't need to declare it here, right?
Okay.
Yeah, get rid of line 15. Get rid of it.
All right.
Get rid of it. All right. Now go back to where you were. Now you can say int. Yeah. You say instead of computer remove, int n equals. No. Int n equals 4 minus remove. N equals 4 minus remove. Semicolon. Now get rid of the next line. Yeah, you can actually triple click, Agnes. It'll be easier than dragging your mouse. Yeah, dragging your mouse gets very stressful after a while, because you got to have multiple faculties engaged, right? When you drag. Right. Okay. So pile. So pile minus n. Pile minus n. So you can say pile minus equals n. Pile minus equals n. Instead of saying pile equals pile minus pile minus equals n, right? In fact, I'll show you how to refactor it even more, right? Much better. You can say, oh, you need n because you need to say. No, I think you're good. All right. So where you say on line 34, you say pile minus equals n, right? Copy everything on line 33 from, they actually 4 minus remove, right? 4 minus remove. Copy 4 minus remove, and then put it instead of put it in place of n on line 34. We basically got rid of a variable. That's what we did, right? And get rid of line 33.
Oh, whoops.
Yeah, that's much better, isn't it?
Yeah.
Now here, instead of n on line 34, you can say I took remove pebbles, because you didn't take. No, you didn't take remove pebbles.
Is remove?
Did you take remove pebbles?
Oh yeah. No.
No, you didn't take remove pebbles. You took 4 minus remove pebbles. No, you took 4 minus remove pebbles, not remove pebbles. The user took remove pebbles, and the computer took 4 minus remove pebbles. So go to line 30. No, where you have the highlighted line. No, remove is so when you play with the user. I'm actually playing the game with the user, right? So when the user types 2, that means remove. User types 1, right? The user wants to remove 1 pebble. Remove equals 1. Right? Everybody following me? Remove equals 1. Now, I, as a computer, gonna take 4 minus 1, 3 pebbles out. Yes or no?
Yes.
Okay. All right. So where you say I took, not here. Oh, this is user input. Okay. Right. See, so that's where variable naming comes in useful. You got to pick the variable names so that you don't have to put in a comment like Agnes just did.
So it could have been like user remove.
No, let's come back to that later, right? No, leave it as leave it like that, right?
Yeah.
So now you can say 4 minus remove pebbles, right? And you can also put 4 minus remove within parentheses, just to be clear, because we're using multiple operators there, right? You're using the less than operator,
like this?
left shift operator, and the minus operator. We don't know what the precedence is, so you can put 4 minus remove within parentheses. Okay, is everybody okay with this so far? Great. Okay, now you have this check, right? If pile is less than or equal to 0, you win. Is that how you do it? No, if pile equals 0, you win, right? If pile equals 0, I win. How did you guys do it? Now, what happens was, what just happened was, after the computer took the last bit, right? The pile is 0. Is that what you're checking?
I think we had it where if you were the one to remove the last, you lost.
Oh, but you did that already. You did that already on line 29. You said if pile is less than or equal to 0. Yeah, actually, you shouldn't say sorry there.
So this,
right?
but this isn't gonna happen, right? Do we need it?
Yes, that is not going to happen, but we're, I'm trying to follow. Now I'm not, not in refactoring mode, logic understanding mode. Let's actually go into the logic. So on line 29, when you say pile less than 0, let's break it up into 2 conditions, right? So yeah, if it is less than 0, it is actually an invalid number. You cannot ask to pick 3 pebbles from a pile that only has 2 stones in it. Yes or no? Okay, so let's just break it up into 2, because if it is less than 0, it's an invalid. You need to go back to the top. So let's say if remove is right on top, when you after you get removed, right, let's go to line 25. Let's actually go to line 25, right? And say if remove is greater than pile. I think can we actually rename some variables so that they all look yeah, is that all right with you guys? Can we rename the variables now? Yes, part of the refactoring. Okay, good. All right, so let's just pick on pile, right? Go right to the top where you declare pile. All right, double click on pile. Right, so it's not pile, right? So pile is not a number. Pile is, in English, pile is not a number. So we shouldn't call a numerical quantity pile in computer science, in programming. Is everybody on board with that so far? Because technically it's okay. What you've done is correct. As far as non-English programmers go, that is fine. But you wouldn't see that happen in an English programming community. You can't call that pile. So I'm going to change that now. All right. So double click on that and right click now. Double click and then right click. I want to see if it gives you an option to refactor. Yeah, right click.
No, it's just.
So it doesn't.
Yeah, it's just the browser.
All right, so let's pick a name for it. And pile size. Now, pile size is a more intuitive name for the pile. Yes, or let's say not pile size, because pile size seems like static right at the beginning. Let's say what do we want to call it? Number pebbles left or stones left. Just call it stones left. Or pile count. Just call it pile count for now. Come up with a better name later, okay? You spend a lot of time coming up with the right names. Yeah, pile count. Pile count, and change the rest of them to pile count also. Double click and copy into your buffer, and then double click paste, paste, and so on. The double click on pile count. Not there. Control Z. Yeah, double click on Control Z.
Oops, sorry, my friend.
No, Control Z will get you to. Right now, double click on pile count. I'll show you the easy way to do it. Double click on pile count.
Yes.
Double click on pile count. Double click.
Yes. Yeah.
Why is only pile highlighted and not the whole thing?
Oh, it's because I already replaced all the piles with pile count down here.
Oh, you already did it. Oh, I'm so sorry. I didn't know it let you do that.
Oh, no. Yeah, I didn't know either.
Thank you, Agnes. I thought we were still
somehow came up.
Great. So pile count. All right. So pile count. Now, after you've got pile count, after you've got remove, let's not call it remove, right? Let's call it.
Yeah.
Let's call it. And now, because it's a lone variable, let's not have the declaration out there. You're not even assigning anything there. Move it right to the top under on line 7. And let's call it. User input. Just call it user input. User int, because it's going to be an int, right? User int. Okay, let's call it user int. We'll come up with a better name later, maybe. Right now, after you've got user int from the user inside of the while loop, there are pile count pebbles left. Yeah, remove 1, 2, or 3. All right. Now see and remove. Yeah, user int. Okay, good. On line 19, we're going to check user int. Right. On line 19, we're going to check user int. If user int is we're going to do the other check. We're going to say if user int is greater than pile count. If user int is greater than pile count. In fact, you can, It's not pile count, right? At some point, I think we should change it to pile size. I think pile size is a much better and also shorter word than pile count.
Should we just change it now?
You can if you want, right? If it's not going to take a lot of time.
Anand, I have a class.
Oh my gosh, is it time already?
No. I have a class in high school that I
Oh,
need to go to. Can I leave?
yeah, sure. Zayed, you can leave. Hey, by the way, you are progressing along, right? You're not having any difficulty, I hope.
No difficulty. I
Good,
understand this.
All right. Thank you, Zayed.
Thank you.
All right, go ahead. All right, good. So hey, if on that size, no, go back to that line and we can. What are you doing now? Oh, you're changing all the.
Oh, just the text portion. Just going again. Okay, so
Great.
here we
So
are.
on line 25, you can say if what is it? User int is greater than file size. Int is greater than file size. On the next line, you can see out a message to the user saying you cannot pick more stones there or than the file contains, and then you can exit one.
Pick more stones
than the file contains. Yeah, and then an end line, and then exit one again.
Reliable exit.
One. Yeah, and then that's it. On the next line, now you know you can safely reduce file size by user int. Yes. So now you have file size minus user int, and now you can say if file size equals 0, it's not never going to be less than 0 because it is less than file size. Oh, less than. Yeah. It's guaranteed to be less than or equal to file size. Yeah. So if double equals 0, if double equals 0, sorry, you lost. Now you know for sure that you lost. Sorry. And you don't know. You don't have to say sorry anymore, right? You took the last stone, right? You took the last stone and therefore you lost, or something like that, right? I won because you took the last stone, right? Yeah. Sorry, not sorry. Okay, whatever, right? You lose. Sorry. Okay. All right. Great. Okay. And this is not an abnormal exit, right? So you can say exit 0 or return 0. Since this is main, you can just say return 0.
Ah.
Right? Yeah, return 0.
It's just 0, right? I think.
Yeah, return 0. So it's a normal exit, right? It's a normal exit where the user lost, but it's still a normal exit. It's not an abnormal exit. So return 0. All right. Now we know, right? So now we know how much to take, right, from this file. So a 4 minus user int is how much we should take from this file. So we take 4 minus user int. Now we check to see if the file size is 0, right? And we know for sure that the file size is, if the file size is 0 now, we won the game, right? If the file size is 0. No, if the file, you can just check to say, because we know double equals 0. If file size
I think this one we still don't know if it's less than or equal to 0, or do we?
Which one? No, we know it is less than or equal to 0. Yes.
Or when the computer takes?
No, we know when the computer picks, we know for sure. Oh, I see. Hang on, just a sec. 4 minus. I see. When the computer picks. Oh, I think your logic is probably. I haven't looked through the logic yet, but maybe it's wrong. Let's take a look. Let's see if the user, if you had 5 pebbles, and the user picked 1. Hey, so this is some bug in the code. You can't pick 0 pebbles, right? In your if I picked I can pick 4 pebbles, so I cannot pick 0, 1, 2, or 3. So -1, -2, -3. So I will end up picking 1, 2, or 3 pebbles. But let's say after that there were 2 pebbles left. You picked 1 and 2 left, right? So which means I'm going to be asked to pick 3. And there's only 2 pebbles left. However, I win the game because less than 4 pebbles left. So you need to have a separate condition for if there's less than 4 pebbles left, you just leave 1 and pick everything else. But that should fall out of the logic automatically. It should. I haven't thought this through yet. I'm just working on this on the fly. But I think if I think about this, we should be able to fold this into the overall logic that if there's 4 or fewer pebbles left, you just take everything except 1, and that should come out of the logic. 4 minus how many ever you picked. Is that the right one? I think the logic is wrong, guys. Where did you get this logic from? I think what you have to do is always pick as many pebbles as needed to get to the next multiple of 4. Because that's how you can make sure that when the size of the pebbles is going down, it will always end at a multiple of 4. You will never. So if you're above 4 pebbles, you end up at 4 when you give it to them. No, when you get it back, or something like that, right? When you get it back, if it is a multiple of 4, you can make sure that you take out as many as to go to the next multiple of 4, or something like that. You got to make sure that the logic is right. I think there's a problem with the logic. I'll think about the logic after class today, right? And I'm sure if you look it up too, but don't look it up. You can. There's some issue there. If someone can narrow it down, that'd be great. But let's look at the structure.
So if you're saying that you take the random number, and then based on that, the computer, based on what the player chooses, the computer chooses a number that will turn the pile size into a multiple of 4 so that they can just go into the winning strategy.
I think that's how the strategy could possibly work, because if you have a predictable position from where you can pick stones at any time, and assuming that 0 is a multiple of 4, you can always force that person.
Well, it needs to be a multiple of 4 plus 1, correct?
No, it needs to be a multiple of 4 plus 1. Yes, multiple of 4 plus 1. Yes, so that no matter what they pick, you can always go back to the multiple of 4 plus 1.
Yeah.
So how do we get it? Did we get it to the right place? So how much are we picking? We're just picking. Yeah, so you need to modify the logic here. Who was it that was just speaking to me? Was it Hiram or?
It was Josh.
Josh, yeah. Thanks. Thank you, Josh. Are you at Foothill today?
Yeah, I am.
You just don't have a camera on.
Oh yeah, sorry. It wasn't.
Hey, by the way, if you're inside of KJ's Cafe.
I'm not.
Yeah, but if you're in there, you'll have much better Wi-Fi. So for Zoom, it'll work much better.
Okay.
Yeah,
Thank you.
All right, cool. Yeah, so you got to, can someone work on the logic later, right? Well, you need to do what Joshua just said, which is basically every time the computer picks pebbles, you need to pick as many pebbles as to get the pile size down to a multiple of 4 plus 1, right? If it is a multiple of 4 plus 1, except 0, except 0. No, 0 is fine too, right? Assuming 0 is a multiple of 4, right? So if you get it to that place, then that person can never pick enough stones to make you pick the last one. There's going to be at least 2 left at any time, because they can only pick. So assuming they can pick 3, right? That's the maximum they can pick. And there's 1 left, or 2 left, right? So 5. 3 picked, 2 left. You can pick 1 and leave the 1 to them. So you want to go to a multiple of 4 plus 1. Can someone change do you want me to change it now, or is someone happy to change? We'll do the refactoring and then do the change in the logic and then post the revised code. Can someone agree to do that? Nobody?
I could try.
Yeah, we can always try.
I'll have to look over it and then try
Even
something.
If it's wrong, it's okay. Even
okay.
if it's wrong, even if it's wrong, it's okay. Because if it's wrong, what we're going to do is basically, just fix it and repost it or something like that, right? Well, I'll get back to you.
Of course, I got
messaging. We'll fix it, but I think it's okay. Or we can all work on it together too. Online. Post it. Right, so fix the logic. Multiple of 4 plus 1, right? And then at the last line 40, right? And you say if pile size equals 0, which should never happen, right? On top, you can put a comment saying that should never happen, right? This should never be hit. This condition should never be hit if we play the game right, right? Right? No. If pile size equals 0, we win because we took the last. Oh yeah, that's right. We took the last one, right? Yeah. You win. I took the last stone, right? So I took the last stone. You win, right? That's much better than just saying you win. I took the last stone. You won. On line 42. On line 42. Yeah, I took the last stone. Hooray! I took the last stone. You win. Right? So it should be a hooray because they won, right? But it should never win. It's only the program who will now because they can look at the source code, right? Because innocent users, they can look at the source code. They think they're going to win. I'm going to win. I'm going to win. I'm going to keep playing, right? They keep forking out money. But someone who looks at the source code knows immediately. Hey, right here, look at all the money coming in, right? Those stupid users think they're going to win, but we know they're not going to win, right? Okay, cool.
What is this?
Get rid of it. We don't need that.
Yeah.
You're right. So, all right. So I think that is pretty much the whole code refactored, except for the logic that you guys have to fix. I cannot think of anything else that I need to refactor right now. But if we look at it, I'm pretty sure we'll come across, other ways in which we can modify the code. But this is some basic refactoring we did. Essentially what we did was, get rid of some indentation, change some variable names to make them simpler, and then move some of the logic around so that, downstream logic can be simpler. And then one of the conditions we broke into 2 conditions, right? The pile size, we broke into 2 conditions because it made more sense. And it also, the program, I think, was easier to read. Was that, sensible or reasonable changes? Maybe you don't agree with all of the changes, but they just need to be reasonable, that some other programmer could think this way. Yes or no? Good.
Yep.
Was this useful? This refactoring exercise, was this useful?
Mhm.
Yeah. All right. Thanks.
I like it.
I'm glad it happened. Also, along the way, we learned about RAND, right? RAND, which is a useful function, especially since we're going to be writing so much code around games and all, right? So this RAND is going to be very useful. Right? Learning to use RAND, and look up our Reddit discussions on RAND. In fact, I think 2 quarters ago, I had a challenge where I was going to pay $100 to someone to prove something about a RAND function, right? In C++. Nobody took it up, unfortunately. Yeah, so I can open it up again. We'll see if there's any interesting discussion. But yeah, we did a lot of interesting stuff today. What time is it? Yeah, we got 10 minutes. Do you guys want to play around with the code on your own? Yeah. And maybe change the logic right now before Agnes or some of you post it on Reddit. You guys want to do it? We got about 15 minutes. So you guys, I can disappear as usual, and you guys can play around with this code. Unless you have a question, for me to talk about or answer, I'm happy to answer questions. But otherwise, you can fix the logic and play this game. Also, make sure this is exactly the same as what you had before, except for the logic error. Right? I'm not getting any feedback though, right? I'm just talking and nobody is responding. What do you guys say? Jared is the only one who's been vocal so far.
Yes.
I took -6 pebbles.
Yeah, no, I'm looking at the logic.
Yeah.
Oh, I see. So you need more. You need more checks in there to make sure that you're
Hold up.
right. So, but I think now you have the general hang of where to inject checks and how to factor your code. Yes.
Yes.
Do you guys want to play around? I can disappear.
Yeah.
Sure.
All right. You call me, okay? Call me. I'm just going to be. Maybe I'll make a coffee or something, right? So I'm going to be over there. So just call me if you want. Yeah.
Okay.
All right. Thanks. Bye.
Bye.
All right. And if I don't see you before, next week, have a good weekend. Keep questioning. Keep questioning and reach out to me. Right. I'm going to be reading email.
Oh, Agnes, it's the if statement on line 20. We're not checking if it's greater than 3.
20 here.
Yeah, we're not checking if it's greater than 3.
Yeah, I'm not really good at talking and thinking at the same time. Sorry.
So probably if you add
Yeah, another or so
Yeah.
so if it's greater, then obviously you can't pick it. If it's less than 1, you can't pick it. And then so or what, greater than 3?
Yeah, I think so.
Right.
And then
like if we're gonna make it, wasn't there like a list? Like, I don't know, maybe it's too much. Like if we really want them to, because I actually wasn't here for when you guys wrote this. I'm not sure what exactly were the requirements of it. Like you had to pick 1, 2, or 3. That's what it was,
Yeah.
right?
Yes.
So obviously, so in that case, we can just make a list and then be like, here's what it needs to be. I don't know, but it doesn't really matter. But anyway, okay, it's fine.
So
Stop.
how do we fix the computer logic?
Yeah. I'm still not quite sure where the 4 came from. Is it because?
Okay, I
We
actually did it
originally had
already.
it- I had it set for the game to begin with 13 pebbles. So it would work for 13 pebbles. But now that we're doing random, we need
Right,
another
yeah.
way.
Yeah,
Yep.
it needs to be a multiple of 4 plus 1.
Hiram
the
said he did it.
Yep.
And how'd you do
I'll
it?
let you figure it out if you want.
Did it involve a modulo or no?
Yes, it did involve modulo.
Okay, that's what I thought. I'm gonna try it too.
Should I just like post the code for now and then?
I mean,
yeah,
what
I'll
I
figure it
understand
out.
about REPL is that it's possible to have multiple people working on the same file at the same time. So you could like press the share button.
Oh, that's
But-
cool.
Yeah, I tried to reset my password right before I started sharing, and somehow my
I
password
see.
didn't go. So
Yeah, yeah. Okay.
Just post on Discord for now, I think. Yeah, they're like, we sent you a password reset email, and I never got it. So
I just used Google to log in.
Hiram, could you share the map and then maybe we can just go over how you got it?
Yeah, sure, I can. So what I did is I had to account for when my logic would be 0 because we can't remove nothing because that would make the computer actually always win, right? So what I did is I had to make an if statement to make sure that my logic never is 0, and if it is, then it takes 1. So what it is, the logic itself, like for what you want to do most of the time, is pile count -1, and then all of that modulus 4. Does that make sense?
So it's just pile count -1 and then modulus 4. And
Yeah,
then
so
you
in the
check
parentheses,
0.
pile count -1.
hang on,
Modulus.
sorry, I was just uploading it. Where?
So when we're calculating how much the computer should take away,
Yeah.
what you want to do is the formula that you want to use is pile count -1, all of that modulus 4. But the problem is that can be 0. And if it's 0 and we let it be 0, the computer always wins, even if you are using the strategy that lets you always win on a number. Where
Ooh, okay. So instead of an if statement, can we do a max? Like max this or 1?
I don't know. I think it would be a lot harder actually, because
Is it? There's no map like function for max?
You can
I don't
just
understand
use
how that would
if
be helpful
statement.
actually.
Well, did you use an if statement?
Yeah, I did.
Yeah, we can get rid of the if statement, but that's refactoring, so never mind.
So, yeah, it's, so if you just want to type it out, I guess we could do that to replace the line that you currently have highlighted. And then we could like look at it more and try to fix it. I don't know. That's what you suggested, right?
You know, somebody
Isn't the-
else can open up
If you want me to
Replit or,
share, then I can
whatever.
do it.
Yeah,
Isn't
can
the
you
goal
go
for
ahead?
Okay, I'll try to share them.
Isn't our goal
Cool.
to make it so the computer always wins?
Well, the thing is, if we start on a number, then a certain number, then the player can force the computer to lose by using the same strategy the computer uses.
Not if the person
Not if the
going
computer
second
can
has all the
subtract 0.
control.
Yes, that's true. But we go
So,
first. That's the thing, right?
I don't think if you do it right, there's no situation where the player can ever win.
It's maybe true. Wait, then maybe I should try to make some more complicated thing then. Is
I
that-
don't think it's super complicated. I think you just need to check to see if it's divisible
No,
by
no,
4.
it's whoever went first has.
No.
Is it? I'm trying to figure this out. I feel like I could.
I don't think it
Let me
is.
see. If I make
I think the
my
rule
version-
is if the starting pebbles is one more when you modulo the starting pebbles by 4, if you get 1, then the computer always wins. But if not, then you always win. It's like if you have 1 pebble, whoever goes first, which is you, you'd lose. If you have 2 pebbles, you take 1, and the computer would have to take 1, which means the computer loses. If there's 3 pebbles, you take 2, the computer takes 1, the computer loses. If there's 4 pebbles, you take 3, the computer takes 1, and the computer loses. So I think you have to start with something like 13 or 17 or 21, something like that, in order for the computer to always win.
Yeah. I just started with 22 and I was able to force the computer to not win.
Yeah. So maybe we can't do random number. We have to do random number times 4 plus 1 for the starting pebbles.
Hey, by the way, guys, I think in the strategy, who goes first is important.
No, we have the computer. No, we have the player going first.
Oh, then it's very hard for the computer to win all the time, right?
Yeah.
I think until a certain I think until you reach a certain number, it makes it
No. If the player goes first, they can make sure to win. Whoever goes first.
That's what I thought.
Using the same strategy that Joshua, I don't know who was talking about.
Because you first have to get the number down to a multiple of 4 plus 1, and then you can keep them on it.
That's right. Whoever gets there first is the winner.
Yeah.
Okay.
So,
So it all
problem-
depends on what the actual number is.
yeah, if the player makes a single mistake on their first turn, the computer wins in my version. So they have to know what they're doing. But yeah. I think my logic is right. I'm not sure.
I think it's right.
Okay. So should I try to share, or do we want to do it, or what?
I have to go.
Yeah, if everybody has to go, then might as well just do it next class.
All right. See you guys next week.
Okay.
Bye.
You guys.
Bye.
Hey, Fernando, are you here? Fernando? Hey, Fernando?
Yes, Mr. Anand.
Oh, good. Are you ready for an office hour?
Yeah.
Okay, all right. Just sign off from Zoom and then I'll send a new invite.
Okay.